Our next example then is example 3. Three new equations for planes, plane 1, plane 2, plane 3. And as always, we're going to want to identify the type, so we should check first to see if they are parallel. So N1 is 1, 1, 1. You can see that from the coefficients. N2 is 1, 2, negative 3. Or sorry, 1, 2, 3. And N3 is 1, 4, 7. Pretty quickly, we can see that none of them are the same or scalar multiples, so they are not parallel. So that means we can eliminate type 1 and type 2. It's too bad because type 1 and type 2 are the easiest ones to actually figure out after this. So that means it's type 3 or type 4. Well, we just did in the other video an example that was type 4, so chances are pretty good that this is type 3, but let's still check. Okay, because maybe it's type 4, or no, maybe it's something else. But let's see. So we're going to check to see if they're coplanar. So we need, again, to take the cross product between two of them and check its answer with the dot product of the third. Again, I'm going to rush through this a little bit quickly just to save us some time, but I've done the cross product and so forth and got that the cross product of the first two is 1, negative 2, 1. I'm going to now take the dot product between it and the third, and if it is 0, then it is perpendicular. Again, 1 times 1 is 1, negative 2 times 4 is negative 8, and 1 times 7 is 7. And look at this, it ends up being coplanar. So it is coplanar, which means, shocker, that it is type 3. All right, so that means it either is the star or the triangle that has no intersection, or it's the book that has a line as an intersection. So there's either a line or there's not. To figure it out, you are going to assume that there is a line. And to do that, you're going to pretend that you actually only have two equations. Because if it is a line, all three of them will intersect at the same spot. So you're going to actually just pick two of them and find the intersection of those two planes. So I'm just going to go full screen here, or just so we can see the whole thing, because finding the intersection of two planes is what we did last lesson. So I'm going to save us a bit of time here and just say that all of this is exactly the same strategy as what we did last lesson to eliminate x, eliminate y, to get two variables in with respect to z. Let z equal k, and get that this is the line, which is the intersection between plane 1 and plane 2. I used 1 and 2, exclusively 1 and 2, to get this equation. Okay, so if you need more advice or need more review on that, go back and watch yesterday's video. Now, this is great. That means that these two intersect at a line, but we have to check to see if it intersects with the third line. So we have to see if this line exists in the third plane. Excuse me, I've been saying plane lines there. I mean planes. We have found that this line is the intersection between these first two planes. We need to see if it also exists on the third plane. To do that, we verify in 3. Again, remember, I used exclusively 1 and 2 right here. See, only 1 and 2 to solve. So I have to verify in the third. If I used 1 and 3, I would verify in the second. So the third equation, the left side is x plus 4y plus 7z, and the right side is 7. So if I plug this in, it should equal 7, which seems kind of weird because I'm plugging in k's. But there's my x is 1 plus k, my y is 2 minus 2k, and my z is just k. So a little bit of rainbow here. The 4 gets rainbowed to an 8 and a minus 2x. And then if you look, 1x minus 8x plus 7x equals 0. And so all the x's disappear, and you're left with negative 1 plus 8, which is 7. And that means it does verify in the third one. And you can actually see some of that math right there. You see the 1 minus 8 plus 7. So there is a connection, obviously, between these. So it turns out that this line that we found, which was the intersection of the first two, is also on the third plane, which means this must be the book situation. where we actually do have an answer because it verifies. And so the intersection is this line. Had you done this work, all of this, and then verified in the third and found out that it didn't verify, that means it would have been the triangle situation. And there would not have been a intersection. Those are kind of the most frustrating ones because you do all this work to show it's type 3, then you do all this work to get a line, and then you got to verify, and it's not until the very last line you find out that there wasn't an intersection. And it can sometimes get a little bit frustrating. That's why this one I made sure that at least you did all that work and you found the answer. So let's go off and check this one. So here is the one, and again, you see these are the same three equations that we just did, and you can visually see that line. I can color it in, and I have asked GeoGebra to give us the equation of this line. And you see that their equation is not given in parametric, but it is given in the general equation. But you can see there is the direction vector of this line, and there is the point. What we can do to compare ours, you see our direction vector is 1, -2, 1. And so is theirs, 1, -2, 1. They've just used a different point than we have. And of course, any point on this line would have worked. So it's good that we did get this answer. All right, now I'm not going to do another example where it is the triangle because the math is all the same. The only difference is when you get down to the end, it won't verify, at which point your conclusion will not be this. Your conclusion will be there is no intersection. All right, so that's all the work for our third example. Let's move on to our fourth, and I'll go back to the page width so we can see this. And here's our fourth example. Well, the intuitive student would say, well, Mr. Lee, you've shown me a type 2, you've shown me a type 4, a type 3. I bet you this last example is type 1. That's very good intuitiveness. Let's check. -1, 1, 3 is the first normal. -1, 1, 3 is the second normal. And the third normal is 2, -2, -6. And the first two are obviously equal, but the third one is also a scalar multiple. If you multiply this by -2, you should get each of these, and you do. So that means that all of these are parallel. So, surprise, surprise, this looks like it might be type 1, but you cannot prove it is type 1 until you prove that none of these are the same. So you need to find the z-intercept for each of these to make sure they are distinct. This one is exactly like the one that we did before. So if I go 0, 0, and I bring this across, it'll be a 2, and divide by 3 is negative, or is positive 2 over 3, so that's 0.1. The next two, again, you bring that across as a 4, divide by 3, that would be 4/3. And this one, I think I can still do this one in my head. Divide by, or subtract 10, so add 10 to both sides, and then divide by -6. So that's going to be 10 over -6, which reduces to, well, that should be a -5 over 3. I'm just going to write that in. I think that's right, -5 over 3. Because this will become a positive 10, and I'm dividing by a -6. So that will be a -pi over 3. Really, all that's important here is that they are not the same. So it turns out these planes, while being parallel, they are also distinct, which is what we were hoping to see. And that means we now can confirm it's type 1. And don't just drop your pencil there, because we have to also say what the intersection is. And obviously the intersection here is that there is none. Okay, and again, I can check on GeoGebra. And if I go to the first one that I showed you, there are those three equations, including that -6 minus 10x. And look, they are indeed distinct and parallel, and so there is no intersection. All right, so in these two videos, well, three videos really, we've seen examples of type 1, 2, 3, and 4, and how to solve the appropriate math to get the intersections when intersections exist. And so now I'm going to give you a couple of practice questions. So here they are. I'm only giving you three, so you don't know which one I've left out. You're going to investigate the common intersection of the planes determined by these equations. Interpret each solution by first identifying the type and then solving when appropriate. So don't forget, after you figure out what type, you tell me whether it's an intersection or not. If it's a point, you solve for the point. If it's a line, you solve for the line. Okay, this is your practice, and I will post solutions to this as well so you can see how you did. All right, good luck with this, and I'm really happy and proud that you have now finished all of your lessons. Take care.